In this video I will be following this blog post here. You see the link over here. It's also in the notebook for this lecture, to show you how you can do a neural network in a Bayesian way. And basically I want you to learn two things from this. First is that doing things in a Bayesian way is sort of a mindset. Yeah, so once you understood the Bayesian approach, you can see there is uncertainty everywhere. And in this case I'm going to illustrate that with estimating a neural network, which we have done before in this lecture series, but now with uncertainty on the coefficients of the network. Yeah, but in principle you can have uncertainty on the architecture of the network as well, so the number of layers or the number of hidden nodes. But here I'll simply do it on the coefficients that we estimate. So that's the first thing that I would like you to understand. And the second thing you can learn from this lecture is that we're simply going to look at a number of different functions that are introduced in this blog post, and I'm going to show you how they work, and I'm going to show you how you could figure out this by yourself. If you're reading a blog post like that and you would like to use the code that is provided there, how you can actually learn what that code does and how it works. So the first step is to generate the data. So from scikit-learn we use a couple of functions here. The first one is called makeMoons, so that's actually generating our data. From scikit-learn we have this scale function, which scales our variables. There is train test split from scikit-learn, which splits the data x and y, which we generated above here, into a training and a test set. And then we can plot our data. Yeah, so let's plot the data. So if you look at this code, you may be unfamiliar, for instance, with this function here from the pymc3 library. So what you do, if that happens, if you come across something, then you simply type in the function with a question mark, and you run the cell, and it will actually explain to you what this function does. Yeah, so in this case it's something that converts, in our case, a NumPy array to something that Theano can understand as well. Theano is the backend of pymc3. Yeah, so if you come across functions here that you're not quite sure of what they do, you can simply type them in to your Jupyter notebook with a question mark. Yeah, so another one, for instance, might be scale. And again, when you type that, you get a separate window explaining to you what scale does. Yeah, so remember, when you read the code, that's how you can figure out what things do and how they work. So now look at the plot. So basically what the plot does is we have our variable x and y. And y is either 0 or 1. And in this case, when y is 0, it's a blue dot. Yeah, you can see it in the legend as well. So when y is 0, we have blue dots. Y is 1, we have red dots. And basically what we want to do is we want to train a neural network that will give us a line here that separates the blue dots from the red dots. So how did we generate this graph? So we look at the scatter plot, and we say take our x variable, select only those values of x where y is equal to 0, and take the first coordinate, so that's what the 0 is doing here. So that's basically the coordinate on the horizontal axis, so that's x1. Then again, from this vector x, we only focus on the case where y is 0. And now take the second coordinate, so that's the coordinate here. And then it plots all these red dots. Yeah, we do another scatter plot where we say now choose the values where y is equal to 1. So these are the ones that we want to color red. So that's why you see color red here as well. And we label them y is equal to 1, and the other one we labeled y is equal to 0. Yeah, so that's how we generated this plot, by making this selection over here with y equal to 0 for the first line. That gives me the blue dots, and y equal to 1 in the second line, which gives me the red dots. Yeah, so what we want to do is to find this line that actually splits these two sets, the red dots from the blue dots. And because this is a Bayesian approach, we actually want to understand what the uncertainty is of this line. Yeah, so we're going to train a neural network in such a way that we can also understand something about how sure we are about where this border is between those two sets of data points. And in order to do that, we basically want to evaluate the neural network that we are going to estimate for each point in this grid. So for all points here, we want to ask our model, what would your prediction be at this particular point, even if we don't actually have data points at that point. Yeah, so in order to be able to do that, we're going to create a grid. I'm going to explain a bit how that works because we haven't used that the grid function yet. So we define a grid. And again, we're going to use this float x function. And the grid is created by this numpy mgrid function, which looks slightly intimidating. So we're going from -3 to +3, and we want 100 steps between those two. I'm going to explain this and illustrate this in a second, so don't worry. 3 and 100 steps. And then we're going to say that the grid that we're interested in, so it's a two-dimensional grid, is equal to grid reshape to -1 transform. So let's see whether I didn't make any errors. So that seems to be fine. So to understand what's going on here, let me illustrate this in a sort of more step-by-step approach. So we're using here the mgrid function from NumPy. And you can use that in a number of ways. Oops, that's the wrong brackets. So first, let me use this without the j, where the j actually indicates a complex number. So we can do this, 0, 1 steps, 0.25, and if we evaluate that, we're going to get a grid. And basically what this notation means here is that we're going from 0 to 1, but not including 1, and we take steps equal to 0.25. Yes, you can see that happening here. So indeed we have 0, 0.25, 0.5, 0.75, but not including 1. Yeah, because that would be the next step. But the endpoints here are not included. Yeah, so that's what happens if we don't use complex numbers. But actually we have complex numbers here. Yeah, so then you, without a complex number, you simply specify the step size. But now I'm going to use a complex number. So now I'm going to say, I want you to do this. So the j is a complex number. Now it says, go from 0 to 1 in 3 steps. Yeah, so just to make sure that we understand what's happening. So let's say that here we go from 10 to 11. And we also want to do this in 3 steps. So 3j. Yeah, so we have numbers here going from 0 to 1 in 3 steps, so 0, 0.51. And here we have, for the second coordinate, we have the same thing. So we have 10, 10.5, and 11. Now the grid that we have is actually the combination of 0 and 10, 0 and 10.5, 0 and 11. And then the second row, 0.5, and this 10, 0.5 and 10.5, etc. Yeah, so that's how we want to generate our grid. Now in order to get there, I need to reshape the grid, and I'm going to say I want 2 coordinates, so that's why I have a 2 here. And then I specify a -1 in the reshape, and that basically means I'm telling Python, you figure out what the second dimension is to make sure that actually this is going to work. So then Python figures out that we have 2 rows, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So that's what the -1 does. The grid has a certain dimension. I'm telling it I want to have 2 rows, and you figure out what the other dimension should be. Yeah, but actually to work with the grid that we want to work with, we're going to transform it. So that's going to basically mean switching the coordinates. So now what I have is a set of coordinates 0, 10, 0, 10.5, 0, 11, etc. Yeah, so now I have my coordinates in the format in which I want to use it. So that's basically what happened here in this grid 2D. We did the reshape, we did the transform, so that we have our coordinates in this way over here. Yeah, so basically point by point. So 0, 10 is 1 point, 0, 10.5 is another point, etc. Yeah, so that's basically what this grid 2D does, and what we're going to use it for later on is that this grid now contains all the numbers in here, actually a bit more, because we're going from, as you can see here, we actually go from -3 to 3. Yeah, so we're going to be a bit broader than what we have here, because here we stop at, let's say, -2.5, but we go a bit further. And then for each point in this grid, we want to evaluate the model later on and see what its prediction is going to be of the neural network. Now, in a neural network, of course, there are two different, there are a number of things that we have to specify. Yeah, so like the architecture, and number of nodes in a layer, the number of layers that we have. But we also have to specify the activation functions. And here we're going to use 2 activation functions. So just to illustrate them, I'm going to plot these. So we say NumPy range from -5 to 5.1 with steps of 0.1. Yeah, so this is the standard range, which is simpler than the grid function, the mgrid function in NumPy. So we're going from -5 to 5.1 with steps of 0.1, but not including 5.1. And then we're going to PLT plot range x. And then from pymc3, the math library, we're going to be using the sigmoid function, and we evaluate that for range x. We need to actually get these numbers, so that's why we have eval here. And then the label is going to be sigmoid. The second activation function we're going to use is the hyperbolic tangent. And that's actually available in NumPy, so I'll use the NumPy version here. Range of x. Label is the hyperbolic tangent. And then we want the legend as well. So let's see what that's going to give us. Yeah, so the sigmoid is the blue one over here. It stays between 0 and 1, so we're going to use it in the final layer to get the probabilities for the probability that a particular observation is red or blue in the graph that we saw above. So that's what the sigmoid does. And the hyperbolic tangent has a similar shape, also this S shape, but it goes from -1 to +1. Yeah, so feel free later on to play around with different activation functions in the network that we're going to specify. Now, when we later on look at the code of the neural network, you see that we use this x-shaped variable, which in our case is 2. Yeah, so if I drop the index, x is of, we have 1000 observations, and each observation is 2-dimensional because we have an x1 and an x2 point. Yeah, so to cover the points in the 2-dimensional space. So basically, for our neural network, what that means is that I'm going to have as inputs x1 and x2, and then we're going to have as the first layer 5 nodes. And the second layer is also going to be 5 nodes. And then in the final layer, this is going to be translated into a probability, and that probability will basically be whether the y label is going to be 0 or 1. Yeah, so whether the color of the observation in our graph is actually going to be blue or red.